I want to do an example of the chi-square goodness of fit test. If you haven't heard of the chi-square test yet, or you haven't seen a more in-depth example that goes through what the statistic is and how it's calculated by hand, I would urge you to go back and watch one of my older videos. But this is just going to be an example of its actual use. So a school district uses the following numbers for elementary level students to estimate busing needs each school year. 55% of students will ride the bus, 35% of students will get a ride to school, 10% will walk. In 2024, the following data is gathered. The 0.05 level is there evidence that trends on transportation have changed. Now, the first thing I did is I figured out how many kids were actually part of this elementary school. So I added up the three numbers to figure out how many total there were. And let me write that down. There were 182 students in this group. Now, 55% should have ridden the bus. So if I were to figure out what is 55% of 182, basically I just say 0.55 times 182, I get 100.1. Now, if I were going to figure out how many ride the bus, again, it says 35%. So if I were to do 0.35 times 182, I get 63.7. And finally, 10% of students are going to walk. Well, 10% of 182 is 18.2. This is what was expected. Now, you might look at this and say, well, but you can't have 100.1 people, 63.7 people, 18.2. We can leave these with decimals, even though, of course, it's not overly maybe reasonable to have these as numbers of people. But if you want, you can also round to 164 and 18. But I'm going to proceed through with the chi-square goodness of fit test. First off, just to explain briefly why we know it's a chi-square test is because we have three categories where there's one piece of information in each category. And we're trying to take this one piece of information and compare it to previously known information. We're not trying to compare two groups to one another. We're not trying to take a group and categorize it twice, like, oh, the bus riders also were in this grade or whatever. We're just getting one piece of information for each category. So the null, I'm going to write down chi-square goodness of fit test. On the AP exam, you'd want to write that somewhere, that's what you're doing. The null hypothesis is that the observed distribution of transportation is equal to what we expected. Basically, you could also say the trends haven't changed. The trend is the same. The alternative is that the observed distribution of transportation types or modes, or however we want to say that, is not equal to what was expected. Or what had been true before. Okay, this is kind of our state. Plan. I'm going to put up here. First off, 182, less than or equal 1/10, all elementary students. Yeah, depending on the district, I'm going to proceed through this. It's hard to fail condition 1, in all honesty, without a lot of explicit information. And condition 2 here is that all expected counts, which again, I'm going to write down here. I'm going to say, well, it was 100, 64, 18. Certainly you could write down the whole thing. You don't have to round, but all of them were bigger than 5. Okay. Now the do portion of this, I'm going to do on my calculator. So let's open up our calculator and do that. So the first thing we do is we put our observed counts in list 1, and then we put our expected counts in list 2. You can see I've done that. We go to stat. we go over to our tests and we scroll down to the chi-square goodness of fit test. And you can see I have put my observed in list 1, expected in list 2. Remember, the degrees of freedom is always the number of categories minus 1. We had 3 categories: bus, ride, or walk, and we subtract 1. We hit calculate, and here we are. My chi-square statistic with 2 degrees of freedom is 5.523, p-value 0.0631. Shrink this down quick so I have a little room to write. In our do portion of the hypothesis test, we write down that the chi-square statistic with 2 degrees of freedom is 5.52, and our 5.2, and our p-value was 0.063. So in terms of our conclude, we would fail to reject. And it's because the p-value is larger than the stated significance level. We don't have enough evidence that trends have changed, or to conclude that trends have changed. Okay. So this is how you run the chi-square test, goodness of fit, The state, remember the null and alternative. The null will always be our observed distribution of whatever the context is equal to what we expected. Alternative, that they're not equal. The plan, make sure we talk about the 1/10 rule. Make sure we show our expected counts. The do, we should be able to do on our calculator. And remember the 3 parts of a conclusion. What are you doing with the null? Why are you doing it? And what does that mean in context? If this video helped you, please like and subscribe for more math help.